Okay, folks, it's now top of the hour, and I see that we have our working group secretary online, and we have our first speaker online, so let's get started. My name is Andy Malice. I am the one of the co-chairs of PALS along with Stuart Bryant. This session is actually a joint session, as you can see on your screen, with PALS, MPLS, Deathnet, and Spring. And the four co-chairs for this session of record are myself, Nick Lehman from the MPLS Working Group, Lou Berger from Deathnet Working Group, and Jim Gouchard from the Spring Working Group. Our secretary is the PALS secretary, Dave Sinacrope, who will be taking the minutes for today. And Dave, thank you very much for that. And with that, I'll move on to the next slide. So this is the note well. You've been seeing this all week, so I'm sure you've all had a chance to see it before. And please just take note of it. So the purpose of this meeting, this is a joint session, as I said, of PALS, MPLS, Deathnet, and Spring. This was called to discuss basic architectural issues that have come up arising from new drafts that have proposed a bunch of new applications and uses at the bottom of the MPLS label stack. The Mpls working group owns the basic architecture for what we're going to be talking about. However, there are a number of other working groups that take advantage of the technology we'll be talking about today, especially PALS and Deathnet, which already make use of the bottom of the stack. And we'll be hearing proposals for general delivery functions and SR MPLS IOAM today. We don't expect to reach any final conclusions at the end of this 2 hours, but we hope this will be a productive contribution to the continued discussion of the issues that we have here. We may end up with a BCP document as a result of the work that we're starting here today. So the agenda for today is I'm starting out. I have the first 5 minutes of this introduction. Next, we're going to hear Stuart Bryant talking about MPLS architectural considerations. He'll have 20 minutes to do so. Next comes the Deathnet data plane, and Balazs Varga will be presenting that. Then we have generic delivery functions from Jeffrey, MPLS in situ OAM from Rakesh, and multi-purpose special purpose labels for forwarding actions, and that's from Karidi. Now, if you notice, that does not take up the entire 2 hours. We're leaving 45 minutes for discussion time here, and that's to allow us to have a good amount of time to discuss all the issues that these slides have brought up and that have come up in the discussion. And then Stuart is going to finish us up with a summary for 5 minutes. And also Stuart will be talking about what comes next. One other thing I would like to point out just before I move on in the agenda, what I'd like to do in terms of questions is during the talks from Stuart, Balazs, Jeffrey, Rakesh, and Karidi, please only raise your hands and ask questions and get into the queue. If you have a question for just to on a particular point that comes up on the slide, but we'd like to keep the major discussion for that 45-minute period. So don't actually plan to start a major discussion on any of the points till we come to the discussion time. It's just basically questions for clarification. And in terms of the online resources for this meeting, we have the agenda, we have Etherpad. Please feel free to write notes in Etherpad, just as you've been doing for the other working groups all week. We have the Jabber Room, and I would like to take advantage of my co-chairs to watch the Jabber Room as I present the slides and make sure that anything that comes up important that's in Jabber gets mentioned on the record. And send an email to tickets@meeting@ietf.org if you have any issues with the audio or Meet Echo. And with that, I'm going to close this particular presentation and start up Stuart's slides. Stuart?
I'm working. All right, thank you, Andy. Thank you, and I apologize for leaving my mic live earlier on.
No
Right,
problem.
okay, next slide, please. Right, so why are we having this PAL, what I'm calling a PALS Plus meeting? There have been really quite a cluster of recent proposals that in effect change the MPLS architecture. Been a number of proposals to add metadata after the stack. There's been a proposal to add metadata in the stack. There's a number of proposals to create new special purpose labels. There's also a proposal to do some quite interesting things actually with the SPL bits. Next slide, please. That would be the spare STL bits. So PALS was the why did PALS sort of act as the canary in the coal mine? PALS was the first working group to deploy metadata below the bottom of stack. That is to say, data that was essential to process in order to process the payload that was beyond it. That was the pseudo-wire control word. Deathnet copied this approach, and with the Deathnet control word, which is essentially from the same family. There are some new proposals, though, that would require more than one set of metadata below the bottom of stack. And as PALS chairs, we thought it was important to make sure that the addition of other metadata does not break or change its protocols or the Deathnet protocol. Or if it does, then we need to know what these behavioral changes are, what the consequences and mitigations are. In other words, we're not saying don't do anything, but go into this new world with open eyes. Next slide, please. So none of the proposed changes are large or in themselves significant. However, in combination, they result in complexity. They change the MPLS forwarding model, and indeed the MPLS forwarding model has changed over time anyway. But if they're not done right, they may fundamentally limit future MPLS development. So what we've done is we've called all the interesting parties to understand the needs that underpin the proposals, to understand the proposals, and to develop a way forward that deliberately changes the MPLS architecture to a model that meets our new needs, rather than discover that we have boxed ourselves into a corner as a result of a set of uncoordinated changes. Next slide, please. So it's as well to dwell on the original MPLS processing model, which was an extremely simple and elegant approach that I've always admired the originators for designing. So you take an MPLS label, you look it up, you take the top label and you look it up in the fib, and the fib points you to some forwarding code and some forwarding parameters. So essentially it's a table-driven execution function, and new forwarding, it's only the top label that's processed, so it's very, very simple and lightweight. New forwarding code can be added simply by adding the code, and then you get the label to point to it. So it's very easy to introduce a new function into the design. And the mapping between the label and the forwarding parameters is provided by the control plane. So it's an absolute minimum amount of stuff done in the forwarding plane, in the fast path, and it's essentially a control plane table-driven design. Next slide, please. So a couple of the additional and famous parameters that were added were VPNs and pseudo wires. And the way this was done is that a label was placed at the bottom of stack, and that label pointed to a fib entry, just like we had in the previous slide, and the fib entry told the forwarder to execute a different piece of code with a different set of parameters. In some cases, we needed a small amount of data below the bottom of stack, the control word, and that provided some additional packet parameters. Next slide, please. The original special purpose labels, there was only one, and I think it could only be at the bottom of stack, and it was only processed at disposition, i.e. when all the other previous labels had been popped, and there were only a tiny number of them used in practice. Next slide, please. Well, ECMP. ECMP was really the end of the pure model. Equal cost multiblast is needed to balance traffic over a set of available next hops to minimize congestion by spreading the traffic over the available paths. And there were a number of approaches, but all of them were optional. That is to say, if a router didn't know how to do the ECMP, with one exception, if it didn't know how to do the ECMP, it didn't matter. So P router didn't need to do this. So you could hash the whole stack, or you could add an entry label at the bottom of stack, which was moved as part of the bottom of stack processing label. That's what pseudowire did. Or you could walk the stack and then holistically test if the payload was IP and hash the 5 tuple. That was done quite a lot. Unfortunately, it made some mistakes, hence a recent PALS draft to explain why you really needed to use the control word. But also this led to the world where the first nibble in the control word, the first nibble after the bottom of label stack, it becomes so important to make sure it's not a 4 or a 6. Also, you could walk the stack, find the entropy label indicator, which was from the original SPL set, and if found, load balance on the entry label, which was what followed below. Next slide, please. So we've gone into a world where we're now starting to explore the stack. With half the SPLs used and SPLs becoming more popular, extended SPLs were created. And that meant that just to have a special purpose label, you always had 2 labels. And if it needed a parameter in the stack, that would be 3. So far, there have not been any of those, but there are sort of various requests out for extended special purpose labels because of the limit to the number of real special purpose labels that there are. So it's 2 labels for the forwarder to test. As the number of labels used, we will eventually need hardware to help us, because this is the fast path, and you don't want to do huge numbers of if statements to find these things. But ESPLs are seen by some as a way of avoiding control plane operations at the expense of forwarding efficiency. And this is the antithesis of the original Mpls design. So it's the right thing to do, it's the right thing to do, but remember, it's the antithesis of the original model I showed you in one of the early slides. Next slide, please. So what's the impact of having multiple SPLs in the stack, which people are talking about? And this is more of a problem for the 2 label version, the ESPLs, which take 2 LSEs to do it. For a start, stack space is very limited in some edge routers. Some, it's been quoted, are as short as 5 labels. So by the time you've done some fast reroute, the delivery labels, some VPN information or pseudowire information, and an EL and ELI, there's not much left to do. This has to some extent been changed by the segment routing world, but nonetheless, the size of the label stack is a constant worry. So let's go to the next slide, please. Right, data past the end of stack. So in pseudowires, we needed some additional information for some of the pseudowires we were processing. And so what we did was we put a control word at the end of the stack, and this was disposed when the bottom of stack was reached, because the pseudowire label said exactly what the pseudowire type was, and hence the characteristics about the control word, whether it was there and how long it was, how to interpret it. Deathnet followed exactly the same model. But now we're seeing, one of the things we're seeing, for example, is OAM instructions and other data being put beyond the end of stack. And this now leads us to the sort of combinatorial explosion. Because clearly, if you want to have OAM on the, oh, by the way, I should back up one. So pseudowires and presumably Deathnet do have OAM for themselves at the end of the label stack, and we can tell this by looking at the first nibble of the control word, and if that's a 1, it tells us that there's an ACH present, and the in this world the ACH was mutually exclusive with user data, and there was never more than 1 ACH per packet. So never more than 1 control word, never more than 1 ACH. Next slide, please. So there have been a couple of proposals in the works when we started this. I think there are other proposals that are sort of heating up as we speak. One was to introduce fragmentation, generalized fragmentation. But of course, if you had a pseudo wire with a control word, then you've got to do that at the same time. So we're now in the start of the combinatorial issue. Another one is OAM. Well, presumably, actually, if you wanted to do IOAM, you might want to do fragmentation on a pseudo wire. So that's 3 items. All these proposals propose to add additional data past the bottom of stack. Both at some stages propose to indicate this by the presence of an extended special purpose label. Both proposed to run on packets carrying user data. So this is a live packet. You can't just punt this thing off to the RP to go and have a look. Could be on the same packet, and as I say, other proposals are now in the works. Next slide, please. So some questions. Should we support the use of special purpose labels embedded in the stack to trigger per hop behavior in MPLS, or should we require all per hop behavior to be triggered by the top of stack label? The original intent, I believe, in MPLS was that the top label would trigger all of the per hop behavior, and what you would do is to create a new FEC. But we've shown a great reluctance to create additional FECs, particularly running across the P routers. Should we support SBL at the top of stack to trigger per hop behavior? When should we support the use of SPL to trigger bottom of stack behavior in MPLS, and when should we require that to be a regular label? So there's a few things that I did around SFLs, where originally I was thinking that we would use a special purpose label to trigger this behavior, and I was persuaded by George Swallow and a few others that actually that's not the MPLS way to do it. The MPLS way is to use a real label and a regular label and signal this in the control plane. So we do need to understand just where we set the bar in terms of SPL being a simple way of doing it with no impact on the control plane versus that actually being a more complicated forwarding plane that we could have dealt with by using a regular label. And should we support separate ACHs below the bottom of stack, or should we require that there's only ever one block of metadata and the applications themselves deal with the combinations and permutations? I am sure that there are many other questions. I'm sure many of you have other questions. Next slide, please. So this is an incomplete list of the various proposals. I quickly went through things yesterday to Loa's request to see if I could find them all. I don't think I have found them all, but this is a place to start, and I am sure there will be others. I certainly am minded to write a couple myself. So you know, we're already on the road to looking at these things, and we need to decide what we do before we box ourselves into a corner. That's the end of my slides, Andy.
Okay, thank you very much, Stuart. And I see we have a question from Bruno. Bruno, go ahead.
Thank you, Stuart. Bruno from Orange. I have a clarification question on slide 10.
Okay, wait 1 second. I'll go back to slide 10.
You said that the stack space is limited, and I agree with you. But next, the slide after, you propose to add data after the stack.
Yes.
So my question is whether it is easier for hardware to access data after the stack or within the stack. And so why is it an improvement to put data after the stack?
Because normally you would process data after the stack on termination. Now,
Okay.
IOEM, of course, doesn't do that, and we have a whole interesting problem as to whether IOEM will be operating on machines that can reach that far into the packet. But most additional data is used at termination when you've already popped the majority of the stack. Others may take a different view, and I'm interested in that. One of the things that people should remember is that forwarding buffer where the network processor operates on is incredibly expensive memory. And so we need to use it with care. That's why a lot of these routers can't, or forwarding engines can't look that far into the packet. Does that address your question, Bruno?
Yes, thank you. But just one follow-up. Some limitation in terms of label stack are on ingress, and the ingress does need to push the stack on anything after the stack.
Indeed, and that's also one of my worries.
Okay,
because you segment routing guys will want some of this stack as well, and we can't all have huge numbers of labels.
I'm aware. Thank you.
Okay,
Kariti.
and yes, Kriti is next.
Hi. So a couple of points. Thank you for this presentation, Andy, Stuart. This is laid out a lot of the questions that we should be looking at. Some of them we should have been looking at for a while, but it is what it is. It's better to do it now than not to do it. So if you go back to the simple forwarding model of MPLS before we started doing all.
Be about slide 4 or something, won't it?
Yeah.
That's it. Slide 5.
Yeah.
That's it. That one.
Right. That one. Thank you. So the thing that is missing here is the fact that the MPLS label gives you a pointer into the fib entry, but the TTL bits and the TC bits are also used. So the TC bits, not for forwarding, but for packet handling, as in how do I queue this, do I drop it, and of course the TC bits. And the TTL bits are just 0 or 1, and I'm going to drop the packet. So the TTL bits is not so much, but the TC bits are sure. So the reason to bring that up is for things that are on the top, for labels that are on the top of stack, those are the bits that are interesting. For labels that are below the top of stack, which I think the next slide talks to a little bit. Can you guys hear me?
Only just, Kariti, but sufficient. For me to hear your commercial for your presentation a bit later.
Well, so the point is that when you get beyond the labels at the top of stack, which for whatever reason, people have been commenting you're not treating this truly as a stack if you're looking at anything beyond the top of stack. And of course, if you pop it, then you're allowed to look at the next one. But while keeping it there, you're doing stuff with it. Beyond the top of stack, what you were doing was looking just at the field that you hear called MPLS label, which you're looking at from the point of view of, is it a special purpose label, or do I take its contents into my hashing machine? So the way we process the top of stack and the way we process things below the top of stack have changed. So I think those, the fact that, and that's why I want to say that the top of stack is not just MPLS label. Otherwise, you could say everything you do below the top of stack is the same as what you did on the top of stack.
No, in fact, it's quite interesting, isn't it? Because in some implementations, they automatically do TTL decrement. So you could never be quite sure what the TTL actually is, other than that it's not hit the safety rails. So so yes, you're in the original model. You weren't supposed to look below the top of stack, And a lot of as we started to do ECMP, the only thing you started to look at was the bottom of stack bits to find the information that followed. So I think I was trying to explain how we gradually moved ourselves away from this pure model. But you're quite right that in this pure model there was another constraint which you never look below the bottom of below the top label, and there was also the difference between the handling of the TC and the TTL bits, which I didn't explain in this.
Okay, guys, I would like to move on to one last question for the segment from Robin. Robin, go ahead.
Hear me?
Yeah.
Yes,
Hello?
we can hear you.
Good. So I think that I say that you mentioned the Deathnet and the PW the example, but I know that's the SFC, that's the encapsulation with the Mpls data plane is also important features developed in the past years. So I think that why not take that into account?
Yeah, it was because I'm sorry, I forgot to mention that one, but I was trying to do a didactic explanation. That is to say, sort of a historical sort of approach that gradually took you through the thought process in the evolving model.
Okay. Well, thank you very much, Stuart. And it's time to move on to Balazs.
Hello, my name is Balazs Varga, and I will present the deterministic networking Mpls data plane. So in Deathnet, we have defined two data planes, an IP and the Mpls data plane. Now we will focus on the Mpls data plane, and this document was recently published as an RFC. Let's start with some basics. So Deathnet discussion focus on solution for networks that are under a single administrative control or within a closed group of administrative control. So any solution for large group of domains such as the internet are out of scope. What we intend to achieve with Deathnet to provide deterministic data path. And that means that we can ensure bounds on latency, loss, packet delay variation, and high reliability. So that is the ultimate goal. And in order to achieve these targets, we have defined some new Deathnet Mpls data plane functionalities. These functionalities were grouped in two sublayers, which were specified in the Deathnet architecture, RFC 8655. We have a Deathnet service sublayer that is responsible for service protection, and we have a Deathnet forwarding sublayer. It provides resource allocation for Deathnet flows over the paths provided by the underlying network. So this Deathnet specific function, in order to work properly, they need two information that have to travel with the packet. One is a flow ID, to being able to identify which packets belong to which Deathnet flow, and the sequence number when we have to make some special functionality. It will come very soon. So when we are looking to service sublayer specific function, they need both of this information, both the flow ID and the sequence number. For the forwarding sublayer related functions, what you need is the flow ID. So as we have to provide these two pieces of information, it was quite obvious to look to the encapsulation formats for pseudo wires and to define a Deathnet specific encapsulation format. And also, if you look to this network diagram showing a Deathnet Mpls network, one may recognize that on high level, it looks very similar to a multi-segment pseudo-wire scenario, where the intermediate nodes, which are supporting the Deathnet service sublayer, they act like SPE nodes. However, there are differences, and the devil is always in the details. So let's look to that differences on the next slide, and they are mainly caused by the Deathnet service sublayer functionalities. So in order to achieve this high availability and the service protection, the replication, elimination, and ordering functions were defined. So this replication and elimination for Deathnet, it means a per packet 1 plus n redundancy. And this is a per packet 1 plus n redundancy, not a per path or segment redundancy. So in the middle of this slide, you can see that that very simple scenario where we have, I am not seeing the slide shared anymore. Okay, are you back?
Yes. Wait 1 second.
Okay.
I have no idea what happened there.
Okay.
But go on.
No worries. Okay. So in the middle of this slide, you can see that simple network diagram. On the left side, packet flows are arrived. We have here different colors for the packets, but all of these packets belong to the same Deathnet flow. So the color is just in order to show the order of the packets. So at the replication node, what that node is doing, it is adding a sequence number to the packets and then doing replicas of the packets and send it across these joint paths to the other end of the network, where an elimination node is placed. And that elimination node will check which packet is received. And of course, it will take only one example from the packet flows, for example, with the sequence number 14, and then forward it to the egress point. So practically the price, we are still staying that slide. Thank you. So the price you have to pay for the extreme reliability is bandwidth, because you are using these joint paths. And there is no primary and backup paths. Both paths are active and they are transporting packets. And the other tax you have to pay is at the elimination node, because this is where you have to store some states, because here you are following which sequence number were received and which not. So you have practically here as a history window from recently received packets in order to being able to decide whether it is an extra and I have already forwarded it or not. So if there is packet loss because of any reason, there is a link or node failure on a given path, or even you have a loss because of bit error ratio on one of the links. So these lost packets can be recovered from the packet flow over the other paths. So with such a replication and elimination function, you may cause some out-of-order delivery. So this is why the third function, the ordering function, was defined. In the bottom, there is a very simple network figure, which is showing how these functions are used in a network that is providing Deathnet service. So the replication, elimination, and ordering function are placed in the network between the source and the destination. And as you can see, there can be multiple replication and elimination points in that network. So there is room for optimization. It will depend on your network topology, on the characteristic of your links, and so on. So let's look to the encapsulation on the next slide, how it is look like. So if we have to forward a packet that requires Deathnet service, we take that in a payload packet, add a Deathnet control word. This is containing the sequencing information for the packet. And as Stuart also highlighted, this is also where some OEM indicator can be placed. Then there will be immediately ahead of that Deathnet control word a service label. That is the label used to identify the Deathnet flow at the peer Deathnet node. And then ahead of the service label, there can be 0 or more Mpls forwarding labels, which are used to direct the packet along the label switch path to the next peer node. And of course, we will have the necessary data link and physical stuff. The next slide is my last slide, and it is just showing the format of the Deathnet control word. It is important to highlight that Deathnet control word for Deathnet flows is a must, so it is always present. That Deathnet control word conforms to the generic pseudo-wire Mpls control word definition. We have 28 bits to place sequence numbers. So different sizes of sequence numbers were defined, 16 bits and 28 bits. The sequence number size is Deathnet flow specific. So at each hop along the path, each Deathnet hop where you intend to use the Deathnet control word and the sequence number information, you have to either by the controller plane or locally configured that size. And one important stuff is that the sequence number differs somewhat from other sequence number defined for pseudo-wires, is that 0 is an ordinary sequence number. So it does not have any special meaning in our case. That's it on the Mpls data plane. Thank you. Any questions, comments?
Okay, thank you very much. Next, we have Jeffrey.
Yes, can you hear me?
Yes, we can.
Great, thanks. Okay, so I'm going to talk about generic delivery function today on behalf of my co-authors, Rambanika and Kriti. This topic was actually presented in last IETF meeting. At that time, it was called generic transport functions. It's renamed to generic delivery functions because the wording transport was sometimes confusing to some people. We are presenting here today again for two reasons. One is to provide some updates on this topic. Thanks a lot to Stuart to provide his valuable comments. The second reason is also for the reasons that Stuart mentioned. We want to discuss this in the broader context with consideration of all other similar proposals, not similar proposals, but the proposals that also use the bottom of the stack space. So next slide, please. Very quick overview. We noticed that some IP functions can actually be viewed as independent of IP. For example, fragmentation and reassembly, AESP, and recently we noticed that this topic of in situ OEM and some other functions that I noticed in this week's IETF sessions. We will provide more background in our draft updates. So with that observation, what if we can extract those functions and apply it to any layer? For example, it can be done at IP layer, Mpls layer, beer layer, or even Ethernet layer. And it can be done for many functions. So this has two axes. One is that at any layer. The second one is that any really generic function that is not dependent on any particular layer. So this, for example, this could be between 2 points at layer 2, layer 3, layer 2.5, or whatever layer. Between two Ethernet nodes, between LSP ingress egress, beer ingress egress, or two IP nodes. For now, we are only looking at between the source and destination points, but this hop by hop behavior maybe we are also looking into that as well. Started looking into that, but for now we just focus on the destination between source and destination pair. Next slide, please. So this is one example no, this is the generic header we use for this. The first nibble 000 is for when it is used for Mpls, then it provides a way to prevent from being mistaken as an IP packet. And header length, that's standard. And then we have both this header and next header. This header will have its own number space that gives us different functions, generic functions. And the next header comes from the IP protocol number space. So any header that comes on IP header, in theory, could come after this GDFH. And then the outer header will indicate that GDFH follows. For example, Mpls label could say that will indicate that we have following this Mpls label, there is this GDFH, and beer, there is a protocol field in the header can tell that. IP next header could say that see the same thing, or in fact the Ethernet type can do the same thing. Now, in the case of Mpls, in the current draft, that the label that indicating GDFH follows, that is a signaled regular label. If this GDF concept is accepted and then supported, widely supported, then a special label would be warranted. And I don't think we need to be peculiar about what kind of special label. But anyway, that eventually comes out on the way to go forward with a special label mechanism, then can work with GDFH. Next slide, please. This is an example of the generic fragmentation header. We don't need to focus on this now, but I want to point out that one thing. Actually, Stewart noticed that a byproduct of this generic delivery function header is that in case of Mpls, now you can use it to indicate the payload type that comes after the Mpls label stack. That is not the original intention of this proposal, but it's a nice byproduct of it. Next slide, please. So I mentioned that this is for generic delivery functions that can be very include many of those generic functions, and the in situ OAM comes to this scenario is that we believe that it can be implemented as a generic delivery function. So here we would have this header indicating that this is for in situ OAM, and then following that will be the IOM option and data information. This is only one single IOM header that implement as GDF. Next slide, please. And this is a more complicated scenario where you would have Mpls, IOM, then plus GDF, then plus pseudo-wire with GSH. Now, let's take a look at this more complicated scenario. At the top, you have the LSP label, we call transport label. Followed that, we have the GDFH indicator label saying that, okay, next is GDFH. And there, the first GDFH is used for IOM, and it has a next header saying type being GDFH, means that another GDFH follows, and that the second GDFH here is just a type XYZ, meaning whatever GDF you're doing here, and then it has a next header saying Mpls, which means that after this, is another MPLS label stack, which includes a pseudo-wire label, followed by the gal indicating this is for GACH stuff. So notice that here we have two independent label stacks separated by the GDFH. This concept is not new. For example, a beer header could separate two label stacks. The first one label stack being the transport label plus beer label, and then after the beer header is the beer payload, which could be a Mpls label stack. Next slide, please. So on the mailing list, there have been some discussions on the relationship between GDF and GACH. My understanding is that GACH was designed for MPLS control channel purpose. GAL label and GACH, they are not used for user traffic. The GACH structure does not have the next concept either. Now, GDF is for generic delivery functions over different layers, supporting different stackable functions. AF is applicable to both user and control traffic. So the way I see it, these two are two different things. Next slide, please. Now, what if the GACH or GL is allowed for user traffic? In that case, then the first GDFH could be treated as a GACH channel. This is just to make use of the GAL label in case of MPLS. The GDF structure will not change. We will still have this header, next header concept because it's critical for extensibility, especially for non-MPLS case. Another question was, what if we just extend the GACH to provide a similar functionality? That could be done, but in that case, keeping old names does not make sense, not even for MPLS, and let alone for if we use it for other layers. So in that regard, we think that developing and progressing GDFH on its own is a better option, and it is not reinventing the wheels. Next slide, please. This probably is the last one. Yeah, this is the last one. Yes.
That was your last slide, so we have time for one question from Greg.
So my question is, in your vision, GDFH must always be bottom of the stack?
It is always following a bottom stack label, but after that GDFH, you could have more label stacks. So you basically have different label stacks. You can have different label stacks separated by the GDFH.
No,
but this is
okay.
how we currently design. But depending on the discussions, this may change. But it is for now.
Okay. But indication that you have GDFH following the bottom of the stack. Is it always bottom of the stack, or it could be anywhere in the stack?
Right now, in this current draft, it's always at the bottom of the stack. But as I said, this may evolve. For example, if we started applying this to hop-by-hop behavior, then things may change. We have not thought through yet.
Okay,
yeah, because, okay,
Greg, we're out of time.
It will be interesting to see how it works for the segment routing because.
Segment routing. This is for generic functions. So whether it's SR MPLS, SRv6, or other layers, it should also work.
Okay,
thanks.
That's all the time we have. So thank you very much. And Rakesh is next. Take it away. Rakesh, go ahead.
Yeah, hi everyone. My name is Rakesh Gandhi from Cisco Systems, presenting MPLS IOEM in situ OEM draft on behalf of the my authors listed here. Next slide, please. So the agenda is to look at the requirements and the scope of the draft for IOEM, the summary of the procedures, the discussions, and the next steps. Next slide, please. So this is about transporting the in situ OEM data fields with MPLS encapsulation. The IOM data fields are defined in the IPPM working group documents. There are few of them listed here. And the scope is edge-to-edge IOM as well as hop-by-hop IOM. And when we say hop-by-hop IOM, it also includes the edge nodes as well. Next slide, please. So many thanks to the MPLS RT expert reviewers. A good suggestion came out is to use IOM generic channel for to carry the IOM data with the GSCH, the first nibble being 0001, and then followed by all the IOM metadata that's defined in the IPPM. So this is carried past the end of stack in the MPLS header. And next slide, please. We can skip this slide. We can go to the next one. So it is used along with indicator label at the bottom of the stack. Indicator label tells the node that there is IOM data fields after the end of stack. We have defined two separate labels, one for edge-to-edge case and one for hop-by-hop case. As IOM processing can be heavy, it is important to optimize that on hop-by-hop case. So this way, for example, if you're just doing edge-to-edge, mid nodes do not need to do any processing for IOM. And there are specific IOM option types defined for these two separate IOM types in the IPPM document. So it's clear which one is being carried in which case. Next slide, please. So this is an example for edge-to-edge case where there is an edge-to-edge indicator label with end of stack set to 1 and GSCH for IOM and then the IOM metadata. So one example for edge-to-edge. Next slide, please. So the edge-to-edge IOM indicator label, there are three methods we can use. One method that's been talked about is the extended special purpose label. This is INI allocated label, and both 15 and the label is carried at the bottom of the label stack. There can be a global label that's allocated by a controller. In this case, there is only one label, and it's carried at the bottom of the label stack. And in the third method, it can be allocated by the decap node, and it's signaled. And this is also important because this way the Ncap node knows that the decap node is capable of processing the IOM because of its kind of capability as well. And in this case, the label is also carried at the bottom of the label stack. So these are three options available, and it is up to the implementation to choose one or more. Next slide, please. So this one it talks about the procedure where the Ncap node adds the label stack as well as the option types. and transit nodes completely ignore them, and decap node, when it sees the indicator label, which is the exposed label, it will do IOM processing, which may means taking a copy of the packet and punting it to slow path. It will remove the decap. It will decap the MPLS header and then do the normal forwarding of the data packets. Next slide, please. So this is an example for SR-MPLS case. There was a review comment on how does it work with path segment. So it shows an example where path segment would go just before the IOM indicator label. You will see basically consistency in all of the formats where IOM indicator label is used in case of edge to edge at the bottom of the stack with EOS1. Next slide, please. So this is a second option, hop by hop case. Hop by hop case, again, there are 3 different methods. This is one example where the indicator label is signaled by the mid node. In this case, it would be the top label on the mid node where packet is received, and that indicates not only the forwarding instruction, but also that there is an IOM processing required. So this is one variant of the 3 methods we will look at on the next slide, please. So there are 3 options. One is the special purpose label that's being talked about in this meeting today. It is with 15 carried at the bottom of the label stack. There is global indicator label allocated by controller as well, and again carried at the bottom of the label stack. And the third option here is slightly different than the edge-to-edge case, where it's advertised by the intermediate nodes or decap nodes via signaling or flooding, and it's carried at the top of the label stack. So in number 1, you have 2 labels, but number 2 and 3 case, you only have 1 extra label. Next slide, please. Again, the procedure on Encap and Decap nodes are the same, but intermediate node now finds that there is an indicator label. So it will invoke the IOM functionality processing module and say there is IOM. Something has to be done for IOM there. Otherwise, it's just optimized and packet just gets forwarded. Next slide, please. So the reason for the joint meeting, there is some discussions with how does it coexist with the control word and additional GACH. So idea is that IOM can continue to be at the bottom of the stack. We know a node always knows where it is. IOM processing is heavy. You have timestamp, you have node ID, you have interface ID, many things to be done in IOM. So it's important that you can easily locate where it is, especially on the intermediate nodes, and process it quickly and forward it in the fast path. So this is again, this is carried by the data traffic. So it's important to have a deterministic location processing for IOM. Next slide, please. So this is one example where we have another GSCH. In this case, it's an edge-to-edge case. Packet comes in with pseudo-file label. It's not end of the stack. Looks at the next label, end of indicator label. It's end of the stack. This is a decap node. So finds the IOM, processes IOM, removes the IOM indicator label and metadata, and continues the pseudo-wire label processing along with his control word. So it just inserted this IOM in the processing in the existing pseudo-wire processing path. Next slide, please. So this is another example with 001. Idea is again the same, where IOM is at the bottom of the stack. It gets processed, removed from the packet, and then you continue processing to the wire label along with your GSCH. Next slide, please. So generic delivery function, again, the way I understand it's for ingress and egress node. There is no hop-by-hop processing. So our packet is received with GDH label and IOM indicator label. Idea is the same. You detect IOM indicator label at the bottom of the stack, process IOM, remove it from the stack, and you continue with your GDH processing, just like if you were for pseudo wire label or any other use cases. Next slide, please. There was question. This is not in the draft, but again, this is there as example to trigger the discussion. You have multiple labels, pseudo wire label, GDH label, indicator label. They go in a certain order. You will find indicator label at the bottom. You process it, remove it, go to the GDH. You process GDH, and then the pseudo wire label. So there is a certain order. It can be implemented this way. And as you can see, there is only one end of stack bit or label. It doesn't change the Mpls data plane significantly with multiple end of stack in labels and whatnot. Next slide, please. This is again Deathnet. So the idea would be very similar. Again, indicator label carried at the bottom of the stack with US1. You process, and then off you go, continue with your normal Deathnet processing. Again, this is not in the draft. This is just here for the sake of discussion in today's meeting. Next slide, please. So that was my last slide. And welcome your discussions and comments.
We have 3 people in the queue, and I would like to keep it just there. So, Greg, you're first.
Go to the previous slide, please.
Wait 1 second. There we go.
Next slide. Yes, thank you. So I just wanted to point out, as Balazs explained, the sequence number is used by, or may be used by Deathnet intermediate nodes for packet replication and duplicate elimination function. So putting the sequence number at a variable length, that's definitely very expensive for Deathnet, where we're trying to minimize extra processing and deliver low packet loss and guaranteed latency, bound latency. So that, I think it's really problematic, because IOM size is variable of the header and TOV prior to their sequence number. Okay, thank you.
Okay, that's a great point. So what I'd like to do is actually not have an answer for that right now from Rakesh, but table that to when we get the overall discussion going. Stuart, you're next.
So I think we're going to need to be really careful when we use the terms like at bottom of stack, because there's a whole group of things that want to be the bottom label, and there's also data that we say is at the bottom of stack where most people expect that to be immediately after the 1 in the stack bit, and actually it's going to be somewhere else. So we're going to have to be scrupulously careful with the ordering and the the order of and the position of information after the stack. And also, we're going to have to be scrupulously careful with the ordering of labels. So I would expect to process the F label and then the S label. Once I've got the S label, I would expect to be able to easily find the control word, and that's not obvious how that works, particularly in the picture we've got here. So I think we need to be really, really careful with some of this stuff, and that's why we need this to do this work.
Okay, very good. And one more quick question from Jeffrey, and then we have to move on.
Yeah, can you go to slide 16, please?
Okay, wait 1 second.
Slide 16.
Yep. Right there. There we go.
So in this slide, we have two ACH headers. First one for IOM, the next one for whatever. So my understanding is that currently GACH does not have the next header concept, and it's designed with only one ACH header in mind. And so I don't know how this will work out.
Can I pick up on that? So the channel defines what comes after the channel. So if you wanted to create a new channel type that had the property that there was certain data after it, that you could do. So there's no intrinsic channel type information, but or next header information, etc. But if you understand the GACH type, then you can understand whatever block of data you want to put after it.
Okay, so that is implicit information there.
It's information in the sense that GACH tells you how to interpret whatever follows the end of the GACH. So the GACH type tells you what comes next.
Okay, in this case,
you can create 64,000 of them.
Okay, in this case, can the IOM GACH imply that after it there is another GACH type, or after that it's just data?
You could, if
you
wanted to. You could have, we could allocate a new GACH type that was IOM followed by pseudowire information, if that is what you wanted to do, or was IOM followed by GACH. We've got 64,000 of these things. We do have to worry that that's going to be a table lookup and possibly quite expensive to do if we have too many of them. But the GACH type defines everything that follows.
Okay, if I can interrupt, this is really going beyond clarification. So I would like to really move on to Karidi. And if I can just give one note to Karidi, when you spoke earlier, your microphone was low. So if you could speak closer to your mic, that'd be great. Thank you.
I switched mics. Is this better?
Yes, that is better.
Okay, thanks. So let's get to, I think, to slide 3.
Okay.
Yeah, thanks. So I'm going to, I want to thank you all for starting this discussion and organizing this session, because I think it's important. I think to Stuart's point, I'm going to try to follow his act, and he said, here's where the history is and here's where we are today. I want to focus on here's where we are today. And it's almost like a bookend to his thing. So maybe if you think of it this way, he was good cop and I'm going to be bad cop. I might be terrible cop. I might be not so terrible cop. I'll leave you guys to decide that. When we started, as Stuart said, you looked at the top label in the stack, and you looked at the label value, you looked at the TC and TTL bits, and said, what do I do with this? And the label value tells you what to do. And so, as he said, you go off to look at what the actions are. And if the action was pop, then you could go and look at the next label. If the action was pop and you have the end of stack bit, you'd say, okay, I want to process what's coming after this, but I actually have no idea what it is, except that signaling told me that this is a VPN label or an eVPN label. So I'm going to interpret what comes afterwards as an IP header or whatever. So anyway, that was back in the old days. And then, as he said, things have changed. Where we are today, for a lot of packet forwarding engines, you're looking at the top of stack, pretty much the way that Stuart mentioned. You're going to look at that and say, what forwarding decision should I make? Has the TTL field, give me cause to drop the packet and send an ECMP or, echo, one of those things, saying all hell broke loose. Look at the TC bits and say, what's my traffic classification? But we go beyond that, and we actually start looking down the stack. And so the sacrosanct bits then are the S bits, because you really need to know when you have to stop. And how far down you go depends on your packet processing engine and the capabilities, your buffers and all those things. And what you do also changes. For example, if you find special purpose labels in the stack, you don't feed them into the mill that's grinding out your entropy. So, you get a label, it's a regular label, you stick it in, you grind some more, you stick the next one and grind some more, and then you say, oh, this is a special purpose label, I gotta do something different. So the ELI said, hey, stop right here, look at the next label. In fact, you can stop after the next level because it gives you all the entropy you ever need. If none of that happens and you're not interested in creating entropy from these things, you actually go all the way to the end of stack and say, if I find a nice IP header here, I'm going to use that. And then I'll get the best entropy that I could get, which is also not completely true, but it's better than trying to just take all the labels in the stack. But this is the kind of thing you're doing. The TC bits and the TTL bits of those of these labels that you're looking at don't matter. And having checked with our own ASICs and checked with some Broadcom ASICs, they don't actually process that. So I put this up to tell you this is where we are today. But the problem is the following. If you step back, and again, I'm trying to put a Stuart-like view to this. If you say, what is the architecture of what are the rules of processing a label stack? I want to go further, and I want to say that actually it's more than that. What are the rules? What's the architecture of the label stack? And yes, we say stack, and yet we are not using it as stack. The moment you look at anything below the top of stack, not having popped the top of stack, you're not behaving as a stack. So, but then what are the rules? What's the architecture for everything that comes after the end of stack? And sort of, you can build those up and say, this is the architecture, this is how you behave with the stack. You can push, you can pop, you can look at the top of stack, but maybe now you can do other things. And then you say, for stuff that comes after the end of stack, what do I do with this? But you have to sort of balance that against there are all these new functions we need, and there are all these new things that we want to do. And so it's that push and pull between, yeah, I've got this beautiful pure architecture, and I was like, but how would you do this and that? And I was like, oh, okay, wait. But then there's another piece, which is the power of the current forwarding engines have changed dramatically between 20 years ago and today. And so you could then step back and say, yeah, you have all this nice architecture, but I can do this, and I want to do this, so I'm just going to do this. So, I mean, we were very limited by power back in the day, and one of the reasons, true or false, one of the supposed reasons for doing Mpls was forwarding on IP was slow, it was complex, the ASICs were difficult to do, so let's build a simpler ASIC that'll do that. And that whole rationale for how you build how you design your forwarding architecture has gone away. That doesn't mean you shouldn't have a forwarding architecture, but it does mean that you aren't limited by the power of the forwarding engines 20 years ago. So we have these 4 dimensions that we got to look at. What's the architecture of the label stack? What should be the architecture of the label stack? What should be the architecture of what comes after the end of stack bit? What are the new functions we need and how do we accommodate them? And what's the power, how does that all map into the power of the current PFEs and PFEs going forward? And in fact, how should all these educate PFE designers as to, hey, this is the direction we could be going, so it would be great if you're there with us. So I think this is sort of the nub of the problem that's in front of us. And again, thank you guys for setting this up, and thank you, Stuart, for laying out the problem. So so that's where I'm going to start. But when I wrote this draft and when I wrote some of the suggestions, it was more along the lines of the last one. Here's the power of my PFE, so I'm just going to go ahead and do this. So I am more than happy to step back and say, okay, let's not just do it, but let's try to put some order, some organization to this. So so if you go to the next, well, go forward a couple of slides. So I actually did a bad thing or a good thing. In the same slide deck, I had the slides that I want to use for MPLS as well as this, and so everyone has context. So I think I want to go to slide 9, which is forwarding actions indicator, forwarding actions data. Is this slide 9? So the idea here is to say, if no one is looking at the TC bits and the TTL bits beyond the top of stack, so at the top of stack, you are looking at them and you need to do them to make sure your actions are correct. Then let's use those bits. So for example, when I did the ELI thing, I said, let's only use 20 bits because the only bits that we think are safe is the 20 bits for forwarding for the label. So I'm going to use that for ELI. I could have used 31 bits, 32 bits. The 32 bits would be bad because the end of stack bit is sacrosanct. So I could have used 31 bits. But now I'm coming back and saying, yes, I should have used 31 bits back then. But even for that forwarding actions indicator, for the special purpose label, I could have had all these other bits. And yes, this is a proposal, but I mean, the higher order bit is that instead of just saying, here's an entropy label indicator, or here's a blah, blah, blah indicator, you can say, here's a forwarding actions indicator, which does many things. And the bits that follow in the TC and TTL tell you more about it. So in this particular case, I want to say, with one special purpose label, I want to do a whole bunch of things like, is it no further fast readout? Is there a flow label, a flow ID? Is there a, what's it called, GIS, a slice indicator? Is there OM at the end of stack? And so we can then turn every new special purpose label into a label that says, I have a lot more information for you. And sort of like the ELI, say the fields that follow me also have more information. And the bits that I have here are going to tell you whether that information exists or not. So in particular, if the forwarding actions indicator has the N bit turned on, if it remains as defined here, the N bit basically says, don't do further fast readout. Well, it doesn't need any more data. It just says, if you ever come into a situation where you need to do fast readout, I'm just telling you that it's not a good idea. And how you get that and all is orthogonal. It needs no extra data. But if you basically say, I'm an entropy label indicator, then the label below me is an entropy label, except now it's all 31 bits. And in fact, I use the EG fields not as independent flags, but as a 2-bit field that say, depending on the value, the next word is a combination entropy and GIS, which is the slice indicator. Or in, if I really need big numbers for them, then I could have an entropy followed by the slice indicator. So basically what you have is a single special purpose label saying, I can do a lot more. So given that we have about 8 left, and we have requests for about 6, maybe 7 of them, what you're seeing is a way that we could say, take one of those 8 and do 6 or 7 things with it. And then when you get, when you're exhausted, you get to the next one. If you use the same architecture, then you can do multiple things as well. But that is more of the, I can do this and I need to do this, and not so much of the architecture of how you do this. So it is good to then say, okay, here's a nice idea, and it, like I said, if people have, they know of forwarding engines, hopefully not things that are 5, 6 years old, because we do want to move forward. We have to worry about legacy. I'm not saying no, but let's first say, what can we do? But then say, how do we put this in a context that we can do more, right? So the idea here is to say, how can we use 31 bits out of the 32 bits, whether it is for the special purpose label or for the data that follows it, as opposed to what we're doing today, which is we use the 20 bits for the special purpose label, and we only have 15 of them, and we only have 8 left, and we use 20 bits of each subsequent label because we are just terrified of using any of the TC bits or TTL bits. So that, I mean, in a nutshell, the proposal is that. But I think the other side of this is we also have all these pressures. I mean, Spring has put a lot of pressure on the label stack because it makes the label stack so big. So if you say, oh, just go to the end of stack and look for the IOM hop by hop label data and go do what you need to do, that's a difficult thing to do. And in the course of discussing how ELI and EL should work together, we actually started thinking about, should we put the ELI on the top of stack? So normally at the top of stack is your label that tells you what to do. But should we put it on the top of stack? And so you sort of say, oh, there's an ELI here. So I'm going to grab the next label, which is the EL. Then I'm going to grab the label after that, say, okay, that's the forwarding label. And then maybe, if it's an adjacency, say, I'm going to pop it. I know what to do now with the label, with the packet. Then I'm going to stick these back on. And then I'm going to do that every hop. And we seriously thought about that for a while. And that's a huge problem with this is no longer a stack, but it's also a huge problem with, can my forwarding engine do this? So we ended up by saying we can put the ELI multiple times inside the label stack. And so, and we came up with this notion of readable stack depth and all. So we sort of built things kind of ad hoc. And I think where we are now is we should step back and say, what is the architecture of the label stack? What are the actions you can take on a label stack? How do you do this in the context of big, deep label stacks, especially as mandated by Spring? And when we do get to a label, if it's not at the top of stack, is it different from a label that's at the top of stack? So I think those are the bigger questions. The rest of the questions, if these questions are answered in this group, then the rest of the questions are the questions for the Mpls working group. Okay, what label do we allocate, and what do these bits mean? I'll stop there. I want to say one other thing before I stop. The idea that there's a label stack and a post-label stack, the label stack tells, by and large, it tells you how to forward the packet. And the post-label stack says what to do with the packet now that you've gotten to the egress. And that generally works. IOM breaks this. IOM basically says, I need an indicator in the label stack. And I don't agree that it should be at the bottom. It could be anywhere. But, and I'm telling you that there's something in the packet that you might want to do something with in transit. And it's not a matter of going to the end, at that point, the label stack has been pretty much popped, and now you're just processing the packet before handing it off to the next thing, which could be, to a CE router. So that's another thing that we need to fit into our architecture. So
Okay.
yeah, I'm done.
Okay, thank you very much, Kariti. I see that what I'd like to do is open the floor for general discussion of everything that we've heard so far, plus anything else that's on your mind that's relevant, of course. And I see that Rakesh is the first person in the queue. So, Rakesh, go ahead.
Yeah, hi, Kirti. This is Rakesh. If in this picture that we are looking at, so this is always going to be at the bottom of the stack, right? So at the midpoint, you would have to scan the label stack?
So this doesn't have to be at the bottom of the label stack. And so one of the things one could think about, and one of the things that I started thinking about, didn't put in the draft, but did put forward the idea that these labels can repeat. So the idea is, for example, I could have a forwarding actions indicator that says, I'm just going to have these bits that say what's coming up next, and I'm not going to carry the associated data, or I might carry a subset of the associated data. The idea of that is essentially, I have a label stack that's 25 labels deep, and a lot of processing engines can only read 3 labels, 4 labels. So what we call readable stack depth. Then what you could say is, I'm going to put one of these, within the first 4 labels so that you can see it. And then when you get to it and pop it off, then there'll be another one within 4 labels, and so on and so on. So if you do it that way, then there could be a packet processing engine that says, I look at this and, oh, it says that there's hop by hop OAM. Do I want to? What would it cost me? But could make a sort of a more rational decision. Let me go to the end of stack and find that and do what I need to do, and then come back and then keep going, right? And if it can't do it, it doesn't have to do it. If it doesn't have any hop by hop OM data, oh, good, I didn't have to parse the label stack just to find that there's nothing to do. So the idea is that this could be repeated, and it could say, look, if you want to, there is not necessarily hop by hop IOM data, but there is hop by hop end of stack data that you would have to pass the whole stack for. Depending on your budget and so on, you can do it or not. So and you can put this pretty high up. So if you say, normally I'm just going to pick up 4 labels from the stack and I'm going to process them and keep going, then if this occurs within that 4 labels, it could say, hey, if you care to and you have the capacity, go for it, because there is some interesting information for you at the end of stack.
So if it's not at the bottom of the stack like that, it could break existing network if it's still running the current code and not upgraded, right? Because if you introduce new semantics in forwarding, Node would not know how to process it.
Well, I mean, if you introduce a new special purpose label, that's going to happen. So what you're going to get is, you're going to get a new special purpose label here. So the forwarding action indicator is a new special purpose label. And it basically says, I'm this funky new special purpose label where these bits that come, the TC bits and the TTL bits are supposed to tell you what to do. And if you don't understand it, you have 2 choices. Well, this should never be on top of stack, because there's no guarantees that the TTL will be anything meaningful or the TC bits will be anything meaningful. So take that, that is a very big caveat here. So you're looking at this forwarding actions indicator and say, I don't know what this is. And you have a choice of dropping the packet or ignoring it. You definitely don't want to put this into your entropy mill, grinding out the next hash value. But beyond that, if you drop it, yeah, that's you're not breaking anything.
Yeah, that's the tricky part, is that where does it go? And if it's at the bottom of the stack, or if it's at the top, you have pros and cons, and this is where I think the challenges come.
So first of all, for any new special purpose label, for whether you use the TC bits or not, you have this problem. It's a new special purpose label, and if the forwarding engine doesn't know what to do with it, it could. I mean, there's some prescribed behavior, but it is different. So the least thing is to just say I'll ignore it. The worst thing is to say I'll drop the packet, and it doesn't matter whether you're using the TC bits or not. But the second thing is, whether this is at the bottom of stack or top of stack or somewhere in the middle, not top, but near the top of stack or somewhere in the middle, and whether it's repeated, the idea here is that it can be repeated. Now, if you think everyone along the path is fully capable and always willing to parse through 25 labels just in case, yeah, you can do it that way. But I want to be able to optimize, because we have multiple types of PFEs. Some which will never be able to process this, but some which can process this at a cost. And if I push this up to the top, I can tell you up front, there is something, if you want to go get it, go get it. Not, oh, all the time, go to the bottom of the stack and see if there's something interesting. So that was the idea.
And the forwarding action data would always have s equal to 1?
Always have s equals 0. So the data depends. I mean, so for example, if the EG, okay, again, for the specific example that I put in the Mpls working group, the EG value can have 0, 0, meaning there is nothing. So actually the forwarding actions indicator itself might have s equals 1. That's why I said s, not s equals 0 or s equals 1. The forwarding actions indicator, EG value of 1, 1, for example, says the next word is entropy. The word after that is the slice indicator, because you want them both to be big. And so you've got 31 bits of each. And so you get the entropy label have a S of 0, and the slice indicator having an S of possibly 1 if there's nothing else going on. Or there could be a VPN label below that. So, you know, it's open. It's not, this is not, this entire thing is not necessarily at the top of the bottom of stack.
So you could have all bits set, and you could have VPN label, entropy label, slice label. So you could have another set of labels. So what is optimizing is the you just indicator labels are less, but you still have all of the other labels in the action data.
Yeah, if you go back to the example that you had 25 labels for a source routed path, you could then stick this in every 5 labels.
Could I suggest that maybe we're a bit in the weeds here?
Yes.
Because this is only one proposal. I personally think it's quite an interesting one, but it's only one, and we need to go up a few levels and understand, things like whether we have a problem and what we're going to do, etc. And when we actually if we do the real work, when we do the real work, then we will be really down into the detail of the design of Kariti's packet, if that is one of the routes we choose to go forward.
Thank you, Stuart. And we have another person in the queue. Hayu?
Hi, Andy. Is that time for general comments? Or
yes. Go right ahead.
Okay. Thank you, Stuart, very much. At the beginning, give a very excellent review of about the history of the Mpls evolution. About 2.5 years ago, actually, we started to realize that there will be multiple functions would compete the location of the bottom stack. For example, by then we see the requirement to run a bunch of in-network functions such as NSF, function service chain, and IOAM, institute OAM. And some other we call in-network functions, which will be added in network and may be required end-to-end processing or the hop-by-hop processing. So we cannot borrow the similar idea from the IPv6 by introducing the concept of extension header to the MPLS. And meanwhile, we also try to avoid some pitfalls of the extension headers in IPv6 to make it more flexible. For example, we should allow the user to quickly jump all the extension headers to access original payload. So there's some improvements there. Meanwhile, actually, we publish a bunch of related drafts. One of them is actually talking about how we will indicate the presence of the extension header. In that draft, we actually list quite a few, all the possible ways we can consider at that time. For example, using claim another special purpose extension header label, a special purpose label, or use the extended special purpose label, or use the GAL plus ACH with channel type extension, or GAL plus another label value, and even another approach to use FEC label to be the extension header indicator. In that draft, we've actually list all the pros and the cons of each method. So you can take a look at that. Then we can continue the discussion from there. Also, we in another two drafts we actually provide how the network architecture will allow us to run the user extension header and also the detailed operations. So I think by then, actually 2 years ago, in one of the Mpls meeting, we already gave an introduction of this extension header idea. But by then, it seems there's a little interest in the working group to consider this issue. But I think now maybe it's a good time to restart it. So that's why we also revive all these drafts, and we request a working group to look at those drafts and consider the comments or proposal. Thank you.
Okay, thank you. And I would like to point out that the drafts that Hayu was just talking about are in this list right here. The two draft song drafts that you see right here.
Yeah, the first two and from Lo Anderson. Yeah.
Oh, okay. And which of Lo
version of this? I've got a new version of this slide, which has got I think draft Zeng. I think I missed one that was brought up in this discussion, and so I'll get Dave to upload a new version. Yeah, that's the one.
Okay.
So I've added your draft, and I'll get Dave Cinecrope to upload a new version of the slides just for posterity. I'm sure it's still short of a few though.
Okay, thank you. Anything else, Hayu?
No, thank you.
Okay, thank you. And Jeffrey, I see that you're in the queue.
Yes. Can you hear me?
Yes, we can.
Okay. So I want to re-emphasize the intention of our proposal generic delivery function. One big reason there is to make it applicable to many layers, including but not limited to MPLS. So I would like to ask people to consider this aspects seriously when we go forward. In one example, in C2 OEM, it can be done for MPLS. It could be done to beer, which is a multicast forwarding paradigm. Then it could be even be applied to Ethernet directly. So it would be nice that when we design a new functions or new extension headers for MPLS, let's consider that if we can abstract it out so that it can be applied to other protocol layers as well.
Okay. Torlis, you're next.
Hi, yeah, I wanted to comment on what Stuart called the weeds from Curity, and I think that's an important layer of the problem. Obviously, we may only want to get to it when we've, gotten down to it with respect to, agreeing on the importance of all the use cases represented and so on. But some note on the weeds here, and I think what Stuart and Kiriti nicely presented is that we've done a little bit of a very much ad hoc, hacky evolution of the MPLS forwarding plane, but yet it is the most flexible encoding of packet processing that we have. And if I look over the over the curtain into, let's say, what Spring is doing with the different variations of an SR header in V6, and where also the question is always coming up, well, what can be done and what cannot be done in various different forwarding planes. I think that unless we want to continue down the rabbit hole of just doing hacky increments that are the smallest change possible, I think it would be good to have a bit more of a strategy on how to define something like an encoding language that can be agreed upon in a way that then the N+1 extension will also work. And I think we have done that in other areas in the IETF, let's say with the management plane in Yang, with the control plane in CBOR, but we haven't specified that type of encoding language for the forwarding plane. And maybe this would be a time to start it. And there is an adjacency, I think, to P4, which also doesn't have a good encoding language for variable headers. If you look at it, it's all very much based on very static TLV headers. So maybe this weeds is something that maybe the IETF shouldn't just do alone here for this particular case, but maybe reach out to that adjacency of P4, because they're also, I think, should be and may already be looking into more flexible headers.
Okay, thank you. Rakesh, you're next.
Yeah, I have one comment add to what Jeffrey said, is that one important aspect of hop-by-hop processing is that we should avoid having to walk all the metadata or even go inside the metadata to find out that Midpoint needs to do some processing. It should be in the header itself that tells you that some processing is required, or just skip it.
Okay, thank you. Robin, you're next.
Hello?
Yep.
Okay. So regarding this, Jeffrey's the general delivery the function. From my point of view, I think that's the scope may be too big. The first one, I think that's the extension mechanism is apparently learned from the IPv6. I think now that's the most popular is already defined. That is for the IPv6. I think for the Ethernet, I think is a little difficult to use this general delivery functions. On the other hand, for the beer layer, I also doubt that one, because the beer already can be encapsulated in the forwarding plane or the IPv6 the data plane. So if the beer layers have this the general function delivery, for the Mpls, there's also the general delivery functions. So I think this causes the replication or the confliction. I think that's now it seems we better we only defend the IPLs header is okay.
Okay, Jeffrey.
I don't agree with the Jim's comment there. I don't think we are talking about the same thing. If you take a look at example of fragmentation or in situ OAM, those are the functions that currently only defined for IP. but it can certainly be done for MPLS and for beer, the beer layer without using IP if we go with the generic delivery function. But that's a bigger topic. We don't have to talk about it today. But more importantly, my point is that anything, while it's a bigger topic, but it's going to be to have landing point in MPLS or in beer or in SR-RISC, wherever. Basically, my request is that whenever you design a function for MPLS layer, just please keep in mind that ask yourself, can this be extracted out to other layers? And also to add to Rakesh's comments. Gee, I forgot what he was talking about. Rakesh, could you remind me what your comments were?
Yeah, hi Jeffrey. The comment was that I think we should optimize the midpoint processing of packet. So header MPLS label or indicator should say there is a processing required, as opposed to going in the various GACH or metadata and figure out that I need to do something or I don't.
Okay. So I think you were, now I remember a little bit more. I think you were talking about hop by hop behavior versus edge to edge behavior. So my comment was about that. So indeed, currently in the current draft, we are only talking about edge to edge function, but it's obvious that these hop by hop functions are some other functions that the people are also thinking about, and I believe those functions can also be abstracted out to be applicable to generic layers, and we will definitely look into that. We believe that we can make it work with generic delivery function as well. But I need to do more homework, and we can continue the discussion on mailing list.
Okay, and the queue is starting to build, so I'd like to go back to Robin quickly. Robin? Oh, Robin is offline. So, Tarek?
Hi, this is Tarek with Juniper. My comment is about the multiple gash, the use case for having multiple gash, and the proposal of having a gash type indicate the multiple and the order of the gash gash channels carried after the bottom of stack. So if one type would indicate, let's say, gash type 1, gash header 1, gash header 2, and another type would say for gash header 1, 2, and 3. I first of all, I don't know if that is how indeed the types are being allocated by IANA to indicate what follows after. Second, I think if it is, then it's too cumbersome to, the number of combinations. For every combination, you will have to define a type. So I'm not sure that is the right road we want to be on.
Okay, thank you. And Wei Cheng? Wei Cheng, go ahead.
Now?
We can hear you now.
Okay, just a minor comment for this page. The third bullet, this draft has been adopted by Mpls working group, so that currently have been the working group.
Wei Cheng, you're breaking up. I'm afraid that we lost Wei Cheng. So, Robin?
Jeffrey, this is the comments. I little confused for this because he mentioned the fragmentation and this is the is this is the IPsec, this is the security. this is the extension header. I wonder that is for the Ethernet layer or the beer layer, or this is the Mpls layer. Are there such use cases, or this is the popular? This is the functionality should be introduced in the different data layers.
Okay. I was just texted that what Wei Ching was trying to say is that Draft Chang was adopted by the Mpls working group. That was his point there. Robin,
we do need to build a better list of the drafts, and we will do that if people tell us what. If I post this list to the MPLS list, people can tell me what the correction should be, and we'll post a revised list of all the drafts that people need to think about.
Very good, thank you, Stuart. Let's move on to Rakesh.
This is one comment for the Tarek's question is that it's the label plus the GSCH that defines the FEC and the action on the node. It's not as opposed to cascading of the GSCH.
Okay, thank you. Greg, did you have a comment?
It's like two small comments, quick. I can point to RFC 8169. It's a residence time measurement in Mpls networks that uses ACH, and then ACH type defines encoding of what follows the ACH. And I think that will be helpful. That's in response to, I think, the Tarek's question about allocation of ACH types. And I think that will be good to keep it, this RFC, together with list of other proposals, because I see that there is some commonality of what we discussed today and what we've done back like 4 years ago. Thank you.
Thank you, Greg.
Okay,
as I say, we'll build this library, and that's a good. I'd forgotten about that, even though I worked on it. So we should we will build the library of drafts that people need as background.
Yes, Stuart, you did indeed, and it was very helpful and good preparation. Thank you.
Okay, we have 3 people left in the queue, and we only have about 4 minutes because we need the last 5 minutes for wrap up. So what I'd like to do is go to Jeffrey quickly.
Yes, a quick response to Rakesh's comments about using IOM label, indicator label. So we noticed that there is GAL label, there's IOM indicator label, and then there is also GDF indicator label. So if you consider all those together, if we could somehow conclude that using GDF is a reasonable thing to do, then we can use one label to indicate that GDF H header follows, and from there you can demultiplex into a lot of options to implement things.
Okay, thank you very much. Uma?
Hi, I think the question about generic delivery function, I have a question. So the examples given is like, common functionalities like IPsec and fragmentation, and the specific new functionalities like IOM, right? So these are the 2 examples. But I think we need to be careful about even the IPsec case or fragmentation. It completely depends on the data plane, right? So if you have IPv4 and IPv6 fragmentation, how fragmentation is done completely different, and the restrictions there are different, right? Similarly, and the Ethernet is a completely different beast, and we may not do it here, so it's need to be done in a different STO. So I'm really confused about. Then if we come to the specific new functionalities like IOM. Again, IOM defines what needs to be done, and again, it needs to be adapted to the forwarding layer where we're talking to it's done in IPv4 or IPv6. So I'm just literally confused whether it is so much tied to the particular data plane. What is that we're trying to do in the generic delivery function?
Uma, that is a great comment for you to start the discussion on the list. And in fact, we'll be talking a bit more about which list to use before we finish up. And I'd like to give Rakesh the final comment before we go to Stuart.
Yeah, so one comment is that I think the optimizing one indicator label on the stack is, I mean, it's good, but what happens with IOM is that you're not only adding indicator, but there is quite a bit of metadata that's being also need to be added by the Encap node. So it's not just the header length, but also a big chunk of metadata. The good news is that it's sampling thing, so you're not adding on all the packets, data packets. It's you only adding it once in a while. So it's a slightly different use case than some of the other, for example, pseudo-wire traffic that's being discussed.
Okay, thank you very much. And I'd like to go to Stuart now. Stuart, your microphone's off. There you go.
To share my screen. I'm not sure how well this is going to work.
It's
Which screen
starting.
will this share? Allow.
It's starting. Let's see.
Ah, that's not going to work very well, is it? I would like to share.
Yeah, there you go.
Is that working? Okay.
Yes, it's working now.
Okay. Very strange UI. So I was given the unenviable task by my 7 co-chairs of this meeting of trying to predict the conclusions of the meeting. And this would be much, much easier if we did it face to face, but it's really regrettable we can't. So here are my straw man conclusions. It is important that MPLS grows and develops to support the new needs of network operators. The alternative to such a development is stagnation and a path to obsolescence. I think from the number of new proposals here, there's probably some sort of gelling for that conclusion. It's important that any change does not adversely affect the operation of legacy equipment installed in the same network as the new functionality. I will be stunned if we disagreed with that. It is important that any change is both forwards and backwards compatible, i.e. that any change does not limit the ability for further enhancements of MPLS. That is to say, we don't do anything that puts us in the corner. It's important that any change be practical on the forwarding technology likely to be deployable in the reasonably near future. So I've not said it has to work on any old piece of legacy junk, but we've got to have a vision that we could probably, and it doesn't have to be in equipment that's shipping today necessarily, but it does need to be in the very, very reasonably near future. It's important that we minimize the number of changes needed to support the new needs by making changes that provide an elegant approach that satisfies as many of the new and future needs as possible. Now, I have some comments about ways forward. Do you want me to pause at that point, Andy, and ask for other questions, or does any of the other chairs want to chip in?
Just keep going.
Okay, so next steps. So I'm going to argue that from what we've seen today, from the set of drafts and from the number of people here, that there is sufficient interest and urgency, there is sufficient interest in this work to continue. And I would also suggest that there's some urgency in the need for new features, that we probably need to work on this between meetings to progress at an acceptable rate. If we agree on that, then I would suggest that the chairs work with the ADs to determine the best way to progress. So we could have an interim, we could have a specialist workshop, we could set up a design team, or we could do something else. Alternatively, we could just say, well, thank you very much. That was an interesting 2 hours, Andy and Stuart. We'll discuss on the list as usual and progress at the next IETF. So I really need some feedback from people. I'm not quite sure how to get that in the current meeting.
Loa has a comment.
Raise your hands feature.
On the Stuart's last slide, I would actually like to delete the or, so we have 6, 7, 8 points. When I said go to the Mpls mailing list, I meant that we start there and then we see what we can do. Good.
So you don't want to do anything special. You just want to go to the list and see and develop things as normal.
No. Sorry, I want to do both 7 and 8.
You mean okay?
So,
yep. And you want to get? Do you want me to delete that last bullet that I've just highlighted? That last piece of it.
6 and 7 using 8.
6 and 7 using 8. Yes, that. Shall I? So we're always going to discuss on the MPLS list, I think, and we're definitely going to have another meeting in 111, either in your slot or in PALS' slot or whatever else the ADs ask us to do. So I think 8 is the second half of 8 is kind of a given, isn't it?
Yes, absolutely.
All right, so I'll delete that because that's going to happen what may.
Okay.
So now the next question is 6. So we're definitely going to discuss on the MPLS list. Do we need, as chairs, to work with the ADs to work out how we are going to progress this in less than the usual IETF very slow speed?
If any of the ADs would like to speak up here, please, we're open.
I think, I don't know who is supposed to speak up. I would like to see an interim, and whether it's a specialist workshop, a design team, or something else, I don't care, but there needs to be an interim, and this can't be just on the list.
Thank you, Tweety.
Okay.
And I would like to give it to John Scudder.
Actually, sort of waiting to hear members of the working group speak up and provide their opinion, but I mean, based on what I've heard at the mic and seen at the in the chat, and it certainly, I think 6 is a correct statement. So yeah, I do think that just sort of sticking this in the back burner until 111 would not be the correct thing to do.
And Martin also has a comment.
Yeah, I guess I agree with what John said. I'd like to add that I'm not so much in favor of a design team. I'd prefer the discussion to start on the MPLS list or on MPLS and PALS or whatever, but having a discussion that can allow as much people as possible to participate, and then see where it leads us. But indeed, working at faster rate than 3 times a year is a good thing to do.
So, Martin, the Deathnet world had essentially open design teams, which seemed to work quite well. That is to say, there was a core group that used to turn up to each of the meetings, and they met once a week in some cases, once every 2 weeks, with a focused task. But anyone could join and take part in it. And there are good export regulation reasons why you shouldn't have a closed design team these days.
Yeah, so let me clarify my position. I'm not opposed to a design team, but I have the feeling that on this particular topic, the size of the design team could be as big as a working group.
Right. Okay. No, I sort of understand your problem.
Yeah, and just to add one thing, I agree with Martin. And whether you want to characterize that as an open design team or as a focused interim, makes not much difference to me.
Okay, and let's give Loa a chance.
I just have a question on the word specialists in front of workshop. Actually, for me, that indicates that it's kind of closed. So I would like to delete that word also.
I mean, I think actually there's no difference between an interim and a workshop, so I can probably delete that whole thing, can't I?
Yes.
The point about about interims, though, is interims normally, and I'm not quite sure where we are in the modern world, but interims normally happen like once between IETFs, and maybe not within 6 weeks, etc. Whereas a design team is allowed to work more frequently, and normally does it without special AD permission, etc.
Yes. So what I would like to suggest, seeing as we're over time already, is that we continue the discussion of exactly what we should do next on the MPLS list. And I would also like us to focus all of the discussion of this topic on one list, that being the MPLS list. And that way people aren't scattered to 3 or 4 different email lists, and there aren't multiple copies of each email. So let's continue this on the MPLS list. Stuart will update his slides and we'll get them included in the meeting materials for this meeting here. And with that, I would like to thank everybody for their participation. I would like to thank Stuart for both co-chairing and for his technical input as well. And let's take this all to the MPLS list. And thank you all very much, and enjoy the rest of the final day of the IETF meeting.
Thank you, Andy.
Thank you very much.
Bye, everybody.
Thank you all.